So the wind-driven current section is just a few pages after the rotary current section. And here, like I explained in the overview, it's just describing certain areas where the current is almost exclusively caused by the direction that the wind is moving. So there's technically two tables here, this one and then this small one up here. This one right here is just a really quick reference for how you can expect the speed of a current to be impacted by the wind based on the area. So you can see like here in for Boston and Barnegat, for just, generally in Massachusetts, 10 knots of wind is equivalent to 0.1 knots of current. So it's 20 knots, but then 30 knots of wind will give you 0.2 knots. In Diamond Shoal and Cape Lookout, 10 knots will give you 0.5 knots, 20 will give you 0.6, and then in all other locations, 10 will give you 0.2, 20 will 0.3. So this is obviously a pretty generalized system, but just if you want to know approximately what your speed is going to be caused by the wind, this is the table for that. Then here is the table for calculating the direction. You don't need to use any other portion of the book here. It doesn't refer to the index, doesn't refer to the substations. All it is a list of locations where wind-driven currents occur, and then what the direction will be, or how the direction will be changed based on the direction of the wind. It's important to remember here, wind is from and current is to. So if the wind is from the north-northeast, that does not mean that the current is going north-northeast. The current is going south-southwest. If the wind is from the north, the current is going south. So you have to remember that for when you're applying these corrections. But the way this works is at a certain location, it will say, hey, if the wind is coming from the east, go to the west and apply this correction factor, and that will tell you the direction that the current is. So, for instance, if the wind is exactly 090 in Portland, if it's coming from 090, the current you would expect to be going exactly 270, but it actually deviates by just 2 degrees to the left. So anytime it's negative, like it says here, and negative number indicates the direction is a little bit to the left, so you would subtract 2 degrees. Here in Boston, if it was 090, you would add 30 degrees to the direction of the current, and so on and so forth. So let's use the example of Cape Lookout, and let's say the wind is coming from the south-southeast. So the wind is coming from south-southeast, Cape Lookout. You see we have a correction of 100, is that 140 degrees or just 40 degrees? It's really hard to read. I'm going to say 140 degrees. So, what did I say? Wind is from the south-southeast, meaning the current is going north-northwest. And if we remember, north is 000 or 360. Northwest is 315. So north-northwest, if we've got an extra 45 degrees here, north-northwest would be 45 by 2 plus 15, 337.5. So that's the direction that's directly reciprocal of the wind. So if the wind is coming here, you would expect it to be pushing the current this way. However, remember, we just got a correction factor of plus 140. So the wind-driven current will actually be way out here, caused by the wind. It's kind of, maybe it's not 140. Maybe it is just, no, it's definitely, no, it is 40. It's just really hard to read. That 1 right there was just was another ink stain. 40 degrees. So instead of being pushed exactly this way, it's going to be pushed 40 degrees to the right, just based on the geography of the area. So you would add 40 to that. And you would get a value of 17.5 degrees. So the wind-driven current at that location, which I forget what we said, Cape Lookout Shoals, if the wind is coming from the south-southeast, then the current will be going 017.5 degrees true.